So this is a good perspective of a problem that this whole problem, well, it ties in other things, but this whole problem essentially deals with chapter 9, and it never ever actually asks you to do any math, I don't think. Right? So it ends up being a very short problem. Chapter 9 is literally all 4-step problems, but it asks you a free response that has nothing to do with solving anything. So it's just asking you about pieces. So part A is describe what a type 2 error would be in the context of the study, and also describe what a consequence of making this type error. It makes comments if it's going to be something like on an AP test. They're facing budget constraints, but also we are testing so we've got a couple different things to possibly be able to use up here. So what in general would a type 2 error be? Data showed what? So it showed that the proportion is.
It showed that the hypothesis was true, but it was actually
type 2. Wait, I'm thinking through this. Okay, so we would have to say the data showed that the proportion, let me do it in context, of what? What did the data find? But what would the consequence be here? Recreation department does not what? No funding for the purpose. Whoa. So that's the direct thing that's going to happen. So what's the, which means what part from there? This is usually where I say, this part is direct. Now you continue it. So now is when I don't look for a specific answer. So what happens? The proportion of the city's residents continue to be a low percentage. Something about that. So like whatever was bad about the fitness level remains bad. The actual AP proposed answer key says a type 2 error means that means failing to reject the null hypothesis that 35% of adult residents in the city are able to pass the test, when in reality less than 35% are able to pass the test. The consequence of this error is that the city council or the council would not fund the program, and the city would continue to have smaller proportion of physically fit residents than the council would like. That's pretty much word for word what we said there. Part B says the recreation department recruits 185 residents who volunteer to take the physical fitness test. The test is passed by 77 of the 185 volunteers, resulting in a p-value of 0.97. So it does everything for all of step do for you and comes up with your p-value. You don't have to do any of that. And then it says, is it reasonable to conclude a test of significance for the hypothesis test stated above using data from these? What would the p-value of this lead you to conclude? Is that typically what our p-value looks like? So why does this p-value look like this? Well, that ends up being an issue, but it's basically, we wanted it to be below, and we're nowhere close to being below. Not only are we not convincingly below, but we're not even below. So our data is so far against what we thought it was going to be. So that should not mess you up, and this should be a very, very, very easy question to answer. What does a p-value of 0.97 mean to us? Since the p-value is less than or is not less than alpha, we fail to reject the null hypothesis that p equals 0.35. We do not have convincing evidence that the proportion is less than 0.35. You should not be caught off guard because this is a weird number. So there's answer key. Because the p-value of 0.97 is larger than alpha equals 0.05. We fail to reject the null hypothesis. There's not convincing evidence that the proportion of adult residents in the city who are able to pass the physical fitness test is less than 0.35. After all, and it just says what we were talking about, after all, their sample proportion was actually higher than that, so obviously it's not going to have evidence in the direction of less than. And then the last one, describe the primary flaw in the study. Is this chapter 9? No. What is the biggest issue about this whole problem? They were volunteers. Now, this is looking for something very, very, very specific in this problem. What does it mean about volunteers? Can't generalize it to the population. But why is this a bad group? And it requires you to make that connection in this problem. The group that is chosen, which is volunteers, will systematically have different results than those who are not volunteers. Because people who volunteer, like somebody who's really out of shape isn't going to volunteer to go do a physical fitness test. And so let's look at the way they worded it. This is not a randomly selected sample, so you can only generalize the population if it's randomly selected, because the sample was selected by recruiting volunteers, so that's what you guys probably wrote about. It seems reasonable to think that volunteers would be more physically fit than the population of city adults as a whole. Therefore, the sample proportion will likely overestimate the population proportion of adult residents in the city who are able to pass the physical fitness test. So now let's look at it in terms of what they required for this problem to get it right. So everything is an E, P, or an I. E is essentially correct, P is partially correct, and I is incorrect. They looked for 3 different pieces in this problem. The first one, it states that the sample is not random and or says that volunteers were used. I would imagine most of you put that. Describes how the sample is different. So there is a response variable that is being measured. The group that we have would have different response variables than those who weren't selected. So how the sample is different with regard to the physical fitness or other variables related to passing the actual physical fitness test. That's what we're talking about is like our response. And then also addresses the idea of making an inference from the sample to the population by stating that the sample statistic will overestimate the population parameter or that the sample will not be representative of the population. I would imagine more of you would go with this piece of it than the first because of the way that the problem was worded. It didn't say what is the issue and why or how. It just said what is the issue. So I think a lot of people would say it would not represent the population correctly, and that's fine. But the more we get into problems like this, I'm trying to give you perspective of connection to what we're doing in class and the way I grade it and the way things should look versus what an actual AP question will look like and what they're requiring and how it goes into the grading process. Questions on that? All right. Giving you a little bit of perspective without too much yet. And I don't like to bring this up too early. On your AP exam, and I specifically never tell you any of this until now, maybe usually later than this. On your AP exam, you are going to have 6 free response questions. There's going to be 1 free response question of those 6 that counts as 25% of your 6 free response questions. And that 1 question is supposed to be something that I didn't teach you. It's supposed to be something that's not in the curriculum. That's why I don't mention this before now. So what they want out of that is, can you make connections between things that you've learned about? Or can you take something you've learned about and apply it to a bigger scenario that is outside of this class? Now, the good thing is, do they expect a lot of people to get it right? No. Everything with our grading fits a bell-shaped curve. So like if nobody gets it right, that shifts how much it takes to pass kind of thing. So it shouldn't be something that scares you. But if I tell you this earlier in the semester, it sounds more scary than it is now. So flip it on the back. And this is only parts A and B of one of those number 6 problems that counts as 25% of your grade on an old AP exam. Now, I want to start addressing perspective for this problem at this point. You are not expected to get everything perfect on number 6. But there should be pieces of number 6 that are very, very easy and you should get. And because it's a 25% of your grade portion, getting the little stuff right is going to make a big difference. And we always have people who look at number 6, freak out, panic, don't read it, and don't try to answer anything. So I'm just starting to give you a little bit of perspective here. Part A is very easy, and you should be able to answer it. Part B is difficult, and I think they made it difficult because of the way they worded it. So what I want you to do now is do Part A by yourself, and then talk about Part B with people around you.